Piloting a P-61 Black Widow was both an electrifying and daunting mission. As the first American aircraft built specifically for night fighting, its futuristic design and cutting-edge technology seemed light years ahead. Unlike the conventional single-engine fighters, this beauty showcased raw power and ingenuity with her sleek twin-boom design and central fuselage pod. Yet, the thought of dogfighting as an interceptor in the night sky's darkness was enough to chill any pilot to the bone. Clocking in at over 350 miles per hour, the Black Widow could tear through the night sky, powered by her twin Pratt & Whitney R2810 double Wasp engines, each unleashing 2,000 horsepower. This was a technical marvel never before seen in World War II combat aviation. Armed to the teeth, she boasted 4 20mm Hispano M2 cannons and 4.50 caliber machine guns in a dorsal turret, making her a flying fortress. If that wasn't enough, the top-secret SCR-720 microwave radar tucked under her nose made her a predator in the darkness. Every curve and detail of the P-61 Black Widow screamed defiance. Her black-painted form vanished into the night, visible only to those unfortunate enough to fall into her radar's grasp. New pilots felt a cold shiver down their spines at the thought of braving the perilous night skies over Europe and the Pacific. But once they took the controls, it became clear. With her advanced radar technology and pitch-black paint job, the Black Widow reigned supreme. She quickly earned her reputation as one of the safest planes to fly and one of the most lethal foes in night combat, even being able to shoot down enemy planes without ever making visual contact. Early British night fighters fending off German raids were clumsy adaptations of day fighters, lacking the gear for effective nocturnal combat. Watching from across the pond, the U.S. Army Air Forces realized the critical need for efficient nighttime fighters. They demanded a dedicated night fighter with advanced radar and superior performance to intercept and destroy enemy bombers in the darkness. At the time, the Northrop Aircraft Corporation was a relatively unknown player in aviation, having only been active since 1939 as a subcontractor. Despite their limited experience, they seized the opportunity as larger firms like Lockheed, Grumman, and Douglas were swamped with commitments. Northrop won the contract to create an aircraft from scratch tailored for night fighting. The request called for a high ceiling to intercept enemy planes at high speeds, extended loiter time to patrol a defended zone undetected, and enough firepower to down heavy bombers. The fighter also needed to incorporate the latest radar technology, the airborne intercept. In November 1940, the P-61 Black Widow project began. The design was sleek and sinister. It was a massive machine for a fighter at 50 feet long with a 66-foot wingspan. The P-61 featured a twin-boom design and a crew of 3, a pilot, a gunner, and a new addition, a radar operator. This radar engineer would control the compact airborne intercept, eliminating the need for ground-based radar guidance. The Black Widow's sleek form, bristling with weapons, prowled the night skies. It was a magnificent aircraft, ready to strike before its enemies even knew they were targeted. Northrop's daring innovation paid off, creating the world's first dedicated night fighter. The SCR-720 radar system used by the P-61 Black Widow was a crucial component of its night fighting capabilities. Developed by the MIT Radiation Laboratory and the U.S. Army Signal Corps, this radar system played a pivotal role in detecting and tracking enemy aircraft under the cover of darkness. The SCR-720 radar was a significant advancement over its predecessors, featuring a shorter wavelength that greatly improved accuracy and reduced ground echo interference. This radar had a detection range of approximately 5 to 10 miles, depending on conditions. It operated by sweeping the sky with a precision beam using a 30-inch rotating scanner-receiver dish housed in the aircraft's nose under a protective fiberglass bubble. The radar weighed over 400 pounds and included advanced features such as identification friend or foe capabilities, which helped distinguish between Allied and enemy aircraft. One of the critical technical advancements of the SCR-720 was its helical scan antenna system, which allowed the radar to maintain a narrow, focused beam while scanning the sky. This system solved the problem of efficiently directing microwave energy from the magnetron to the antenna. The helical scan system proved effective in providing the necessary precision for nighttime interception missions. Additionally, the radar operator seated behind the pilot and gunner played an essential role in guiding the P-61 towards its targets. The operator would use the radar to track enemy aircraft and direct the pilot for interception. Once the P-61 was within visual range, the pilot could engage the enemy using the aircraft's formidable armament of 420mm Hispano M2 cannons and 4.50 caliber machine guns. The development and implementation of the SCR-720 radar were part of a broader effort to improve airborne radar systems during the war. The collaboration between US and British scientists, particularly in the development of the cavity magnetron, was a significant milestone that enabled the creation of more compact and powerful radar systems like the SCR-720. This technology was vital for the success of night fighters like the P-61 Black Widow, paving the way for night fighters to claim the darkened skies over Europe. Powered by two Pratt & Whitney R2800 double Wasp radial engines, each churning out 2,000 horsepower, the P-61 could hit speeds up to 366 miles per hour, a remarkable feat for such a large aircraft. Its tricycle landing gear, retractable flaps, and 646-gallon internal fuel capacity supported its hefty fighting weight of over 29,000 pounds. A stealthy innovation was its glossy black paint. The decision to paint the P-61 Black Widow in an all-black paint scheme was driven by the need for effective night camouflage. During World War II, researchers at the Massachusetts Institute of Technology conducted tests to determine the best paint scheme for night fighters. This decision was based on extensive testing, which included flying aircraft into searchlights to observe which colors were least visible. They discovered that a glossy black finish provided the optimal camouflage, reflecting searchlight beams away from the aircraft and making it nearly invisible against the night sky. The glossy black paint outperformed other tested schemes such as matte black and olive drab with matte black undersides, leading to its adoption for most production P-61s. This black paint did not require any special technology for its application, but it had to be durable and maintain its gloss in various operational conditions. The main objective was to enhance the aircraft's ability to evade detection by both enemy ground observers and other aircraft during night missions. The effect of this paint scheme was significant in operational performance. The P-61's black finish made it an elusive target during night operations, complementing its advanced radar system and powerful armament. The combination of the SCR-720 radar and the black paint allowed the P-61 to approach and engage enemy aircraft with a higher degree of stealth, increasing its effectiveness as a night fighter. Beginning with the P-61B model, night fighters were equipped with specialized night vision binoculars that dramatically improved the pilot's accuracy in nocturnal combat. These 5.8 magnification optical devices, coupled with an advanced gun sight, provided Black Widow operators with an unparalleled advantage in night fighting, increasing targeting precision by a factor of 4. The binoculars were ingeniously mounted on a track system that allowed them to traverse the aircraft's windows, providing a wide field of view. This carriage was further enhanced by a gimbal mount, which compensated for aircraft vibrations and turbulence, ensuring a stable image even in rough conditions. With practice, pilots could effectively operate the P-61 while looking through these binoculars, enabling them to detect enemy aircraft in near total darkness. The P-61 Black Widow made a dramatic public debut in January 1944 with a nighttime flyover of the Los Angeles Coliseum, packed with 75,000 attendees for an Army-Navy show. The crowd couldn't see the plane. They could only hear its engines roaring overhead, a haunting introduction to America's new night fighter. The 422nd Night Fighter Squadron was the first to fly the Black Widow in Europe on May 23, 1944. Almost a month later, the 425th Squadron received their P-61S. Unfortunately, both squadrons got their aircraft too late to join the D-Day invasion on June 6th. The Black Widow's first real mission was to hunt down the dreaded German V-1 buzz bomb. In the Mediterranean, the 414th Squadron received their P-61S in December. They teamed up with the 422nd Squadron during the Battle of the Bulge, the infamous last significant German offensive on the Western Front. During this brutal campaign, the P-61's limitations became apparent. Lieutenant Van Nyswender, piloting his Daisy May Black Widow, encountered a twin-engined Messerschmitt 410. The chase took them skimming over the treetops. Despite pushing the Black Widow to full throttle, the Me-410 pulled away at 400 miles per hour, leaving the P-61 trailing and highlighting its sluggish speed compared to the newer German fighters. By the end of 1944, the 422nd and 425th Squadrons faced critical shortages of spare parts. As a smaller company, Northrop struggled to keep up with the demand, and the supply issues persisted. The squadrons had to make do with whatever equipment they had. Ultimately, most operational P-61s were sent to the Pacific, where they continued to serve in the relentless push against Japanese forces. Despite its shortcomings, the Black Widow remained a symbol of innovation and determination, embodying the relentless spirit of the Allied forces. After securing Guadalcanal in late 1942, the American stronghold desperately needed protection from Japanese nighttime raids. The Black Widows weren't ready, so the Americans temporarily adapted the B-25, P-40, P-38, and P-70 as night fighters. Finally, in May 1944, the Black Widows were combat-ready. The 6th Night Fighter Squadron was the first to receive them, followed by the 418th and 419th Squadrons. On July 1, 1944, the 421st Squadron was activated, operating from Nadzab, New Guinea and Wake Island bases. Operating the P-61 Black Widow demanded exceptional preparation, setting it apart from most contemporary aircraft. Pilots underwent rigorous pre-flight routines to enhance their night vision. The primary methods included wearing red-tinted goggles for several hours before takeoff or secluding themselves in a pitch-dark room for about 30 minutes prior to a mission. These techniques effectively conditioned their eyes for nocturnal operations. A less common approach involved keeping one eye closed and the other open for an extended period before flight. However, this method was generally avoided as the P-61 manual warned it could induce, quote, disturbing sensations. On one of their first missions, Flight Lieutenant Owen Wolf and Radio Officer Lieutenant Byron Allen of the 421st received orders to intercept an enemy bomber near Owe Island. Despite bad weather hampering their radar, Wolf managed to catch up with a Japanese twin-engine bomber. The Black Widow's nose guns and cannons lit up the night, sending the bomber down in flames into the ocean. The 418th Squadron, based at Morotai, Halmahera's, Netherlands East Indies, operated the top-scoring Black Widow. Despite this, they conducted only 18 successful attacks, their most notable mission destroying 3 Kawasaki Ki-61S in a single night. The P-61's role was limited during the last 6 months of World War II, as the Axis powers were too weakened to mount significant aerial resistance. In more than one report, Black Widow crews claimed to have been able to take out enemy aircraft in utter darkness without ever seeing their target due to weather conditions until it was already falling from the sky. Captain Lee Kendall's Lady in the Dark P-61 is renowned as the most iconic Black Widow fighter in history. This aircraft, extensively photographed in the Pacific Theater, is believed to have achieved the final 2 aerial victories of World War II. The first occurred on the war's last night, and the second came nearly a day after hostilities had officially ceased. In both instances, Captain Kendall downed Japanese Imperial Army planes on kamikaze missions, forcing them to crash through relentless pursuit rather than direct hits. Arriving late in the war, the P-61 Black Widow's impact was limited. Although it proved useful against the Japanese Air Force, it was already considered outdated in Europe. Northrop engineers extensively tried improving the P-61, including redesigning the airborne intercept radar, enhancing the remote-controlled turret, and adding turbochargers. Despite these upgrades, the aircraft still lagged in speed. In Europe, the more advanced British Mosquito Mk-17 gradually replaced the Black Widow, relegating it to secondary roles such as reserve and training. Nonetheless, the P-61 saw action in every theater of World War II, claiming a total of 127 enemy warplanes and 18 German V-1 buzz bombs. Post-war, the Black Widow contributed significantly to a joint study by the Army Air Force, Navy Weather Bureau, and National Advisory Committee for Aeronautics, which later became NASA. A key initiative, Operation Thunderstorm, aimed to study thunderstorms to enhance the safety of military and civilian aircraft. The insights gained from this project laid the groundwork for the modern understanding of thunderstorms and related weather phenomena. Though these post-war roles briefly extended the P-61's service life, it was officially retired in 1954. Despite its late arrival and limited wartime impact, the P-61 Black Widow remains a symbol of innovation and resilience, firmly embedded in the legacy of military aviation history. In the Vietnam War, among the high-flying jets of the era, the Cessna A-37 Dragonfly presented a distinct contrast. This compact jet, tipping the scales at just 14,000 pounds and easily accessible at waist height, lacked the imposing presence of its contemporaries. Pilots could simply step into the cockpit, a departure from the norm of climbing shaky ladders to board more menacing counterparts. Equipped with a minigun that some dismissed as little more than a BB pistol in the fierce theater of war, the A-37 was often overlooked. Yet beneath this unassuming exterior lay a surprisingly versatile warrior, especially supporting ground troops. This humble jet trainer was initially designed for basic flight instruction. No one could have imagined that such a seemingly simple aircraft would evolve into one of the premier counterinsurgency planes of the Vietnam War, the A-37A Dragonfly. In 1952, when the United States Air Force needed a trainer to transition fighter pilots into the new jet age, American ex-aviation manufacturing company Cessna entered their Model 318 concept into the competition, winning. The T-37 model was an inexpensive twin-engine waist-high model featuring a pair of Turbomeca J69 engines and side-by-side seating for a teacher and a student. Its design was straightforward, with straight wings, training wheels, landing gear, which eased the segue from propellers and a simple avionics system. In fact, most students could fly solo after a mere 6 hours of training. With over 1,200 copies produced, thousands upon thousands of potential Air Force jet pilots learned how to fly in this stable, easy-to-fly and easy-to-fly machine with a max speed of 425 miles per hour. Despite this simple ruggedness, which made for the perfect learning environment, the aircraft had a unique feature. Its 21,000 revolution per minute turbine blades of the engines produced a high-pitched squeal. According to lore, some ground crew alums suffered from hearing loss in the upper frequency ranges from the earplug penetrating sound, which earned the model the nickname Tweet. While the T-37 Tweet had already established itself as one of the service's premier jet trainers, it was about to prove it could do much more. In the early 1960s, as the United States' involvement in Vietnam was escalating, the Air Force identified the need for a specialized counterinsurgency coin aircraft. The T-37 was the perfect fit for this role, with its operations ranging from forward air control, reconnaissance, air escort, and most importantly, ground support missions. Looking to acquire the Tweet as a promising aircraft, albeit with some modifications like shorter wings, larger wingtip fuel tanks, a minigun, improved avionics, and specific landing gear, the Air Force contacted Cessna and requested a couple of prototypes. The first, named YAT-37D, flew in October 1964. Despite overwhelmingly positive results, interest in the role had waned by then, and the project was shelved. The decision seemed committed, with one of the only 2 prototypes being sent to a museum for public display. Its story was not over just yet. With the program shelved as the Vietnam conflict escalated even further, the service's top choice for the coin role was the A-1 Sky Raider, a World War-era propeller-driven model. Hard to fly for newbie pilots accustomed to jets and dangerous in low and slow combat environments. By the mid-1960s, the service was burning through their vintage-type stockpile faster than anticipated. Faced with this shortage, the Air Force turned to the Tweed again and contracted Cessna for 39 attack-adapted versions of the T-37s. The A-37 Dragonfly, adapted from already finished jet trainers, was a subsonic light attack aircraft that could lift its weight in fuel and armaments. The model retained most of the original Tweed's appearance as well as its cost-effective price tag, at about 1/6 of the price of a McDonnell Douglas F-4 Phantom II. Despite its diminutive appearance, the model, officially named Cessna A-37 Dragonfly, was much more potent than its jet trainer predecessor. With a weight of 14,000 pounds, fully loaded and powered by a duo of General Electric J85J2/5 turbojet engines, it had nearly twice the thrust of its original power plants, giving it a max speed of 506 miles per hour and a range of 932 miles. Rugged landing gear allowed operations from unimproved airfields, while added communication systems enhanced interoperability, navigation, and targeting. The piece de resistance was a General Electric Ju-2BA 6-barrel 7.62 by 51mm minigun mounted on the nose for easy and accessible use. An electrically powered Gatling gun capable of 3,000 rounds per minute, but carrying 1,500 rounds on board, could make a powerful 30 seconds of chaos upon the enemy, complete with gun sight and gun camera. By re-engineering the airframe and adding a total of 8 external hardpoints, this spunky little plane was upgraded to carry Mk-80 bombs. Finally, a Cessna-made model could fight back. When 25 models were finished in 1967, they were sent to Vietnam for combat evaluations to fast-track the aircraft's development. At England Air Force Base in Louisiana, Lieutenant Colonel Lew Weber, a veteran pilot of the legendary World War II-era Flying Tigers, devised a groundbreaking strategy. He proposed incorporating live combat into the A-37's operational testing, a method never attempted with any other aircraft. According to Lon Holtz, quote, "Other fighters were proven here in the States. They'd gone through their certification, their weapons loading, their maintenance procedures. That's not the case with the A-37. This aircraft went over to prove itself in combat." After getting approval, Weber assembled the 604th Air Commando Squadron, based at Bien Hoa in South Vietnam, and the small Dragonflies were crated and transported to Vietnam in Lockheed C-141S. With it came 30 pilots from all types of experience in the service, from bombers to transports. Upon their arrival in Asia, Cessna employees unboxed and assembled each one. Some pilots and other service workers of more advanced aircraft mocked the kit plane, leading to a nickname upgrade from Tweet to Super Tweet. Weber's theory for the coin roll was to build a rudimentary fighter out of a simple trainer that every pilot in the service was already comfortable with, hence putting it into action fast. With no advanced weapon systems to learn, a rudimentary World War II-style bomb delivery, and without a traditional nearly one-year-long training program, the model was poised to either fail or perform extremely well in an extraordinarily niche role. During the Vietnam War, the A-37 Dragonfly helped set the standard for lightweight counterinsurgency coin roll, one of the most difficult missions in the military. Well equipped for operations from even the most rudimentary of airfields, the model also required very little maintenance compared to more sophisticated platforms like the F-4 Phantom. As such, it was an ideal aircraft for South Vietnamese pilots, which lacked standard American Air Force training but had great men nonetheless. But the biggest reason the Super Tweet flew mostly under the public radar of Cold War-era aircraft was that it never actually flew into North Vietnam, where enemy air defenses claimed hundreds of models. Instead, it remained in the South, Laos, and Cambodia, where the United States ground forces performed daily missions. The straight-wing design of the Super Tweet allowed it to engage at speeds 100 miles per hour slower than swept-wing fighters, enhancing precision and being capable of reaching areas other larger models wouldn't. In a dive, the Dragonfly was a small and difficult target to hit. Its unusual speeds and altitudes often puzzled enemy gunners. The nose-mounted minigun, often described as a BB pistol in combat, had limited capacity to penetrate the dense jungle canopy during strafing runs. Despite this, the Super Tweet proved to be an exceptionally versatile aircraft. This robust little plane was capable of deploying a variety of ordnance, including conventional gravity bombs, cluster munitions, napalm, and unguided 2.75-inch rockets, Although it could be equipped with gun pods that included additional miniguns and cannons, these were reportedly never utilized in combat. This aircraft had 2 seats from the remaining trainer features. For close support operations, it is typically flown single pilot to maximize ordnance load. But when operating as a forward air controller where it coordinated other close support assets, an observer typically occupied the right seat. During its active service, it was the only United States Air Force jet authorized to shut down an engine during cruising in non-emergency conditions. Doing this on one burner conserved fuel for more loiter time above the target. In its first 3,000 sorties, not a single A-37 was downed by enemy fire. Combat Dragon continued, and the very versatile A-37 flew over 10,000 missions in its first year of combat duty, rapidly gaining the reputation of being both hard-hitting and compelling at COIN operations. Combat Dragon continued until December 1967, and after 5 months and nearly 20,000 ordnance deliveries, the validity of Lieutenant Colonel Weber's operational strategy was vindicated. The A-37 could be turned around in as little as 90 minutes, as the Cessna-made model had none of the large fighter's high-maintenance temperament. According to former crew chief Bill McCall, quote, "The 2-to-1 ratio of maintenance to flying hours was fantastic. An F-101 was something like 12-to-1. Give me 2 A-37s and I could literally keep them flying day and night." During Combat Dragon, not a single A-37 was ever lost to enemy fire, only 2 to accidents. That being said, the endless hours and missions of the type led to the realization of many issues, mainly concerning the type's lack of range and endurance. With this taken into consideration, the Air Force continued to improve the Dragonfly, leading to a total of 577 A-37B models. Unlike the original variant, the A-37B was purpose-built. From studying all the flight test combat missions flown during the test trial, the Cessna bulked the model with more thrust from newer engines, larger fuel tanks, and a heavier fuselage, significantly improving performance. The A-37B was even capable of in-flight refueling capability, which extended its range and allowed for longer missions, a critical feature in the prolonged engagements typical in Vietnam. For enemy missions, this newly upgraded model was capable of carrying up to 8,000 pounds of ordnance and was armed with a variety of weapons, including bombs, rockets, and gun pods across its 10 hardpoints. With enhanced armor and upgraded avionics, the A-37B offered better protection and effectiveness for pilots in combat scenarios. The A-37B remained extensively used in the Vietnam War for close air support, interdiction, and counterinsurgency missions. One of the unique capabilities of the A-37B was its suitability for night operations. This allowed the U.S. Air Force to conduct 24-hour bombing campaigns, increasing pressure on enemy forces. Because of its mostly unglamorous missions, most of the A-37 production run went to the Republic of Vietnam Air Force, operating up to 254 of the type. By the end of the Vietnam War, the A-37 had flown an outstanding 160,000 combat sorties with only 22 American Super Tweets lost. However, the A-37 began a new career when the North eventually overran the South, as they captured over 30 intact models. As relatively easy to fly, Communist pilots flew these machines in combat operations against South Vietnamese forces for the rest of the conflict. Overall, while the Cessna A-37 Super Tweet was never as famous as other Vietnam-era models like the F-4 Phantom and B-52 Stratofortress, from 1967 to 1974, according to Air Force documents, the airplane flew 68,471 missions. And today, more than half a century after its introduction, the niche attack jet continues to serve. In the forthcoming years, Vietnam exported the aircraft to a variety of communist states' SAW service, where they continued to serve in COIN operations against drug cartels, predominantly in Latin American nations like Peru, Guatemala, and El Salvador, where it remains active as of 2024. At the dawn of the atomic age of flight, just a year from the shadows of World War II, The Republic F-84 Thunderjet carved its path through the heavens, eclipsing the legendary speeds of the P-51 Mustang by nearly 200 miles per hour. As the first jet warplane to roll off the American production lines en masse, it stood on the brink of revolutionizing the skies. With its sleek lines and straight wings, the F-84 soared with a singular purpose: to redefine the rules of aerial engagement. Abandoning traditional pistons for the raw power of an Allison J-35A-13C turbojet, it shattered the national speed record, thundering through the atmosphere at a groundbreaking 607.2 miles per hour. Yet the Thunderjet was more than a mere speed demon. It was a symbol of a new, terrifying chapter in military strategy. As the inaugural fighter bomber capable of wielding a nuclear weapon, it marked the onset of a fearsome chapter in global warfare. But the journey of this pioneering aircraft, plagued by a litany of mechanical malfunctions and daunting maintenance challenges, it earned the notorious title of Mechanic's Nightmare. As the clouds of the Korean War gathered on the horizon, the F-84 Thunderjet was poised to demonstrate its true mettle, proving that its legacy was not to be defined by early tribulations. As World War II was nearing its climax, Republic Aviation recognized that their 1941 creation, the P-47 Thunderbolt, was on the fast track to obsolescence, overshadowed by the rapid advancements in fighter aircraft design. Jet engine technology appeared to be the future of combat aviation. On September 11, 1944, the U.S. Army Air Forces laid out the blueprint for a day fighter that would redefine aerial combat, a bird with a top speed of 600 miles per hour, a combat radius of 850 miles, and packed to the gills with firepower, either 8 12.7mm or 6 15.2mm cannons. These ambitious specs were later dialed back to a more manageable combat radius of 705 miles and a lighter armament loadout. Banking on Republic's solid track record, the military brass didn't bother shopping around for other manufacturers. Staring down the barrel of the limitations of their piston-engine steeds, Republic Aviation saddled up for the challenge of birthing a turbojet-powered successor to the P-47. This was the Wild West of jet fighter design, where the tech was green and unproven. Nobody had yet engineered a safe, reliable, and battle-ready jet. Each outfit was left to cut its own path through uncharted territory. Amid this storm of innovation, the Thunderjet was born, flying high with other trailblazers like the P-80 Shooting Star and the North American F-86 Sabre. The P-80 Shooting Star heralded the dawn of the jet age for American aviation, clinching the title of the first American jet fighter. However, the F-84 Thunderjet and the F-86 Sabre truly honed the jet fighter concept, pushing the envelope in range, payload, and operational flexibility. The journey began with the Thunderjet's first prototype wrapping up in December 1945. Yet her maiden flight was pushed to February 1946 due to delays in securing engines. Wind tunnel experiments exposed a critical flaw in the design of the vertical stabilizer at high speeds, alongside worries about the aircraft's heft. By August 1946, a second prototype took to the skies. The following month, she smashed a national speed record, blazing past at 607.2 miles per hour and highlighting the XP-84's sheer muscle. Yet Republic Aviation wasn't just gunning to shatter the national speed record. They were hot on the heels of the international speed champ, the British Gloucester Meteor. This jet, the first Allied fighter to roar through the skies of World War II, had recently clocked a blistering 616 miles per hour, despite its older design compared to the Thunderjet. Despite these bumps in the road, the assembly line shifted into overdrive in 1947, with the first squadron of F-84Bs thundering into action by December of that year. The Thunderjet was distinguished by its innovative design features. The nose air intake was at the heart of its aerodynamic profile, a brilliant decision that ensured a smooth airflow to the engine. The straight-wing setup, decked out with wingtip tanks, was the gold standard for early jet fighters, offering stability and extra mileage. The pilot's cockpit cover, starting off as a slick sliding feature, got a tweak with support struts to boost safety for the pilot without messing with the Thunderjet's sharp outline. A tandem landing gear layout gave her the balance and support needed for her sturdy build and hefty weaponry. Packing serious heat, the F-84 was kitted out with 6 50 caliber M3 Browning machine guns, a powerhouse lineup that could lay down a rain of bullets. As her mission profile broadened, clever additions like pylons under each wing and the belly meant the Thunderjet could lug around up to 32 rockets or 4,000 pounds of bombs, proving her adaptability in the heat of battle. In her pivotal role at the dawn of the nuclear era, she was strategically prepared to execute the deployment of the Mark VII nuclear bomb, colloquially known as Thor. This American tactical nuclear weapon, designed for deployment by smaller aircraft, tipped the scales at 1,700 pounds, holding significant destructive potential despite its relatively compact size. The heart of this formidable fighter was powered by the Allison J-35A-29 turbojet engine, a marvel of engineering that represented a significant advancement for the Air Force into the realm of axial flow compressor jet technology. This innovative approach involves compressing air to increase its density before it is combined with fuel to propel the aircraft. The air is directed straight through the engine, where it is compressed by a series of rotating blades akin to fans and stationary blades. This compression process not only densifies the air, but also prepares it for efficient combustion. Marking a considerable leap forward from previous piston-powered engines, this technology enables aircraft to achieve higher speeds and improved fuel efficiency. With her 11-stage axial flow compressor and a single-stage turbine, the J-35 was the picture of simplicity and get-up-and-go efficiency. Slapping on an afterburner flipped the script, catapulting the F-84 into the history book's turbojet flight by cranking her power up to a jaw-dropping 5,600 pounds of thrust, more than double that of the Messerschmitt Me 262, the first operational combat jet in the world. This mix of top-shelf propulsion and heavy-duty firepower locked in the F-84 Thunderjet's legacy as a do-it-all sky warrior, acing both dogfights and hitting targets on the ground while reserving the ability to rain nuclear destruction over her enemies if necessary. At least that's what she pledged on paper. On the field, it was a different story. In December 1947, the inaugural squadron of F-84B Thunderjets was deployed to the 14th Fighter Group at Dow Field, Maine. It didn't take long for the excitement to hit a snag. Pilots were quickly slapped with limits on their throttle, capping speeds at Mach 0.8 and pulling no more than 5.5 Gs, due to alarming issues with the aircraft's skin wrinkling under stress. The maintenance woes of the F-84B soon spiraled, dubbing her the mechanic's nightmare. These persistent headaches forced the entire fleet of F-84Bs to be grounded. Hopes were pinned on the upcoming F-84C to iron out these kinks, but history repeated itself and the new variant faced a similar fate, leading to another round of groundings. Salvation came with the rollout of the F-84D, which addressed and rectified the flaws of the previous models. This variant swiftly asserted her dominance over the Air Force's other jet fighter, the Lockheed F-80 Shooting Star, showcasing marked improvements. Efforts were made to retrofit the F-84Bs and F-84Cs, patching them up for service until their eventual retirement in 1952. The F-84D also bowed out from the Air Force in the same year, but continued to serve with the Air National Guard until 1957, marking the end of an era but leaving a legacy of resilience and innovation. The dawn of the 1950s brought with it the F-84E, a model that represented a significant leap forward from her predecessors, marking her status as the first truly effective iteration of the Thunderjet series. This model boasted a suite of enhancements, cutting-edge avionics, an elongated fuselage for improved aerodynamics, reinforced wings, and the addition of pylons for carrying extra fuel tanks and retractable mounts for rockets under each wing, dramatically boosting her firepower and endurance. Yet the F-84E's potential was clipped by logistical headaches, with parts shortages grounding about half of the fleet at any given time. This operational hiccup led to her phased retirement from the Air Force by 1956, with the reserve following a year later. Nevertheless, the F-A-4E soldiered on with the Air National Guard until 1959, demonstrating her resilience and adaptability. 1951 saw the arrival of the F-84G, stepping up the game with in-flight refueling capabilities, a beefed-up engine, and an enhanced payload capacity. Despite these advancements, the F-84G was essentially a placeholder, bridging the gap until the swept-wing F-84F Thunderstreak could take the stage. The Air Force welcomed 789 units of the F-84G, while its international footprint expanded with over 2,000 units finding homes abroad. The F-84G's tenure in the U.S. service stretched until 1964, showcasing great durability and versatility on the global stage. With most shortcomings addressed or diminished, the Thunderjet would have her chance to shine during the fierce aerial clashes of the Korean War. When the United States decided to jump into the fray of the Korean War, it was all hands on deck to deploy a wing of F-84 Thunderjets overseas. By the time 1950 was wrapping up, these powerhouse jets touched down, kicking off their first missions in December, primarily playing the role of wingmen for the B-29 Superfortress bombers cruising through enemy skies. The Thunderjet scored her first air-to-air victory on January 21, 1951, but this win came at a hefty cost, losing 2 fighter bombers to enemy fire. In the high-stakes dogfight over Korea, the F-84 was outclassed by the Soviet Mikoyan-Gurevich MiG-15. This swept-wing rival outpaced and outmaneuvered it. This underdog role led to a game-changing switch. The F-86 Sabre stepped up to the plate for air superiority missions, leaving the F-84 to strafe enemy troops as a ground attack aircraft. This strategic pivot turned the Thunderjet from a struggling escort fighter into a powerhouse of ground attack might. This new role didn't just salvage her reputation, it catapulted the F-84 into becoming an indispensable asset in the Korean theater, fundamentally altering the dynamics of air-to-ground combat in the conflict. By the time the dust settled on the Korean War, the F-84 Thunderjet had carved out a legendary spot in the history books of military aviation with some impressive stats. Over 86,000 combat sorties flown, over 55,000 tons of bombs dropped, over 6,000 tons of napalm unleashed, and over 22,000 rockets fired. The Thunderjet was a force of nature on the battlefield, knocking out 60% of all air-to-ground targets and snagging 8 air-to-air wins against the tough Mikoyan-Gurevich MiG-15s. The Air Force counted the loss of 305 F-84s during the war, with 249 of those losses attributed to combat. But even with these tough breaks, the Thunderjet's mark on air combat is undeniable. But it wasn't just about the fight. The F-84 Thunderjet also led the charge in aerial refueling and takeoff tech. She became the first jet to ace air-to-air refueling in combat operations. This development took place during the Korean War when F-84 fighters were refueled by modified B-29 bombers. This operation significantly extended the range and endurance of the F-84s, enabling them to carry out longer missions. The F-84G model, in particular, was equipped with a refueling receptacle in the leading edge of the left wing, compatible with the boom-equipped KB-29P, marking a significant advancement in the operational capabilities of fighter aircraft. In 1955, an F-84E powered by a solid fuel booster rocket made the first zero-length takeoff. This bold move allowed the fighter bomber to launch from just about anywhere, even a trailer, proving the Thunderjet's versatility and reliability. As the F-84 Thunderjet stepped back from the front lines, she didn't just slip quietly into the shadows, she vaulted into the heart of American cultural lore, capturing the essence of innovation and bravery. Her storied battle achievements aside, the Thunderjet also morphed into an icon of aerial elegance and pinpoint accuracy, stealing the hearts of a whole generation. On May 25, 1953, the heavens bore witness to the birth of the 3,600th Air Demonstration Team, charged with wowing the crowd, buffing up the Air Force's rep, and showcasing the might of their birds and the slick moves of their pilots. The F-84G Thunderjet was chosen for this prestigious role, becoming the first aircraft to grace the skies with the Thunderbirds, the Air Force's elite demonstration team from 1953 to 1955.